Another way that we start talking about a data set of values when we're talking about statistics is by data distribution. How is the data spread? Not only we talk about measures of center and measures of spread, but how are is that data distributed? Is it evenly distributed? Is there one side or the other that has a few stragglers out there, and that's kind of what we're going to talk about with data distribution. So dot plot is one of the ways that we can visually represent the data distribution, and so it is a visual representation using a number line and some form of symbols to show the distribution of data. These are also sometimes known as line plots. So if you see something called a line plot, they're still talking about a dot plot, okay? The other part of data distribution is discussing what an outlier is. So an outlier is an extreme value. It may seem like it doesn't belong to the data. In a set of data, and that point is much higher or lower than the other data points. It looks like it's outside of the rest of the data, hence the name outlier. Okay, so outliers do have a mathematical calculation to find them, and they're determined by the following characteristics. And so we use X here to represent a data value. So whatever your number is that you're looking at, if that number is less than the first quartile minus 1.5 times the inner quartile range, then it's an outlier. Or if your value that you're looking at, is greater than the third quartile plus 1.5 times the inner quartile range, that's also going to be considered an outlier. Okay. Now, dot plots. To create one, okay, that's what we're going to do. We're going to create a dot plot. You're going to create a number line, but that number line needs to have an appropriate scale. Meaning, if I have numbers that are, between 1 and 10, or, something like that, we don't need to have a scale that's skip counting by 20 and goes from 0 to 100, okay? It needs to be appropriate to the values that I've been given, all right? So we are going to place, once we have that number line, an X, a dot, or some other symbol. Sometimes if you're dealing with a specific situation, you may see something like they would draw a picture that represents that. That would be okay. But most of the time it's an X or a dot above the number line each time the value appears in the data set. So for an example, here we have the data 1, 3, 3, 2, 4, 5, 1, 2, and 2. So we are going to create a dot plot. So here's our number line, and I'm going to pick an appropriate scale. Well, I have numbers 1 to 5 here, and so I'm just going to start with 1, and I'm going to skip 2, 3, 4, and 5. Okay, and I'm going to place an X above mine each time I have one of these values. So I have a 1, I'm going to put an X. 3, I'm going to put an X. I have another 3, so I'm going to put an X on top of that one. Okay, it's going to be vertical, so you can see how many, the frequency of that value. 2, and then I have a 4, a 5, another 1, another 2, and another 2. Okay, and so this is the dot plot here for this data. All right, now the distribution of data can be described in 3 different ways. Data can be symmetric. Okay, it can be skewed to the left, or it can be skewed to the right. Okay, and there are 3 representations of that here below. So this first one, notice it's nice and even. The majority of the numbers are here in the middle, and then there's a few, to the outside. So this is considered symmetric. Okay, notice this one has a lot of my values over here on this side, with a few of these numbers that are kind of outside of that over here on the left side. And so because I have those values over here, my data is skewed to the left, Whereas on this one, I have most of my data here on this side, and then over here I've got a few values. So this is going to be skewed to the right. And it's just a visual representation here. When we see those data plots, it's easy to see how those values are distributed and whether they're symmetric or not. All right, so here we have test scores from the last algebra test. We have 95, 80, 75, 60, 90, 70, 100, 45, 85, 80, 75, and 90. We're asked to create a dot plot with an appropriate scale. So let's start with that. So my values here are from about a 45 to a 90. If I keep reading the question, there's also a student who's going to take a makeup test, and that's going to be a 30. So I'm going to need at least values starting at 30 and going up to 100. So I'm actually just going to start with a 30, and I'm going to skip count by tens here. 60, 70, 80, 90, and 100. And I could place my 35, my 45, 55 in here as well, okay? Just to save room, I'm not going to do that to keep it from being overcrowded. So from here, I'm going to go ahead and place my data on the number line. So I have a 95, I have an 80, 75, 60, 90, 70, 100, 45, 85, 80, 75, and a 90. All right, then we have the student who comes to take a makeup test, and we add that 30 in there. So the question is that 30 an outlier? Okay, so let's put our values here in order. So I have 30, 45, 60, 70, 75, 75, 80, 80, 85, 90, 90, 95, and 100. So all my values here. Got 13 of them. So my median is here. I'm going to have a Q1 value of a 65 and a Q3 value of 90. So first quartile is 65, third quartile is a 90. So let's see, Q1 is 65, third quartile is a 90, and so my interquartile range in that case is going to be a 25. Okay, so I want to know, is 30 an outlier? So I'm going to be using this first little mini formula here. So I'm going to start with the first quartile number, so 65, minus 1.5 times my interquartile range, which in this case is a 25. Okay, so I'm going to do a quick calculation. So 65 minus 1.5 times 25, and I get a value of 65 minus 1.5 times 25, and I get a value of 27.5. So in order to be an outlier, my value has to be less than 27.5. And in this case, 30 is not less than that. So 30 is not an outlier. Okay. And my second question here is the data symmetric, skewed to the left, or skewed to the right? So if I look, most of my data here is kind of on my right side with a few of those numbers out to the left. So I'm going to say that the data is skewed to the left.